Hello guys, in this video I'm going to teach you how data storage works in Docker using volumes. I will explain some key concepts to you and then we're going to dive into some coding action. At the end, I will also give you a project that will test your ability to design and implement solutions using Docker storage mechanisms. Welcome to the 7th lesson of Docker from Zero to Infinity series. My name is Raghav. Let's get started. First things first, why do we need storage in Docker? So that we can run stateful applications inside servers. These are applications that produce and store data on persistent disk storage. This data must be preserved. We cannot afford to lose it. It may be used by the server, client, or other applications. The problem with running such apps inside Docker containers is all data created inside a container only lives as long as that container itself. So if you're running a database like MySQL inside a container in production environment, and tomorrow that container gets wiped off from the host, you lose your data permanently. But don't start crying because Docker does provide mechanisms for you to persist that data on the host machine even after the container dies. So let's take a look at volumes and bind mounts. Bind mounts are how Docker originally allowed persistence. Using this feature, you can mount any file or directory on your host machine onto your container at a specific path. Then, if the app inside the container writes any data at its internal path, the data actually gets written outside the container onto the main host at the host path. So bind mount is really good for development and debugging. You could make changes to your code on the host machine, restart the container, and they will instantly reflect inside it. But it is not the recommended way of doing storage because Docker has no control over the host file system path, and any other processes on the host can easily tamper with the data, causing corruption for the container using that data storage. Enter volumes. Volumes are also host directories mounted inside your containers, but they are created inside Docker's own storage directory on the host machine. The data written inside the container path gets written inside the host path, which is Docker's storage space. The contents of this directory are managed by Docker. Volumes are the recommended mechanism to persist data beyond a container's lifespan. They are also designed for write-intensive applications, such as databases, and can be shared between containers. Volumes are Docker managed. You can perform operations on them using the usual Docker tooling. You can store volumes on remote hosts or cloud providers, encrypt their contents, and add a lot more functionality. So naturally, in this lesson, we will focus on volumes. You can create a volume and then mount it at a specific path inside a container. Then all data gets stored in this volume. Let's see this in action. All right, I'm inside my repository where all the code lives. The link for this repo is in the description below. If you want to do this exercise with me, open up the problem directory. That's your starting point, and I highly encourage that. If you just want to access the whole solution, then go to the solution directory instead. The setup is very simple. app.py is my main application. When it starts, it looks for the data.txt file as specified. If this file is found, the app simply prints the data in it. But if the file doesn't exist, then the app creates it and populates it with data. More specifically, the message defined here. Finally, the app waits for us to press enter before exiting. I created a simple Docker file to run my app inside a container. Main thing to note here is the /data directory I created. My app will store all the data inside this directory. So now I would like to persist its contents. Okay, so let's first build the image. Now, before we start with the fancy stuff, I want to run the container normally once. By normally, I mean just relying on default Docker behavior. Okay, there's no data.txt file already, so the app creates a new one and populates it with data. Good. When I press enter, the app will exit and my container will stop as well. What do you think will happen to the data my app wrote? it will obviously get lost because it only exists inside the container and the container just died. Even if I try to run new containers with the same image, the app will always create a new file because there's no pre-existing data. We never persisted any data. So now let's attach a volume to the container. At the moment, my system has no volumes. Let's create one. Okay, I have a new volume. Let's run a new container again. I'll use the same run command as before with just one addition. I will now attach a volume to the container. First, I specify the volume I want to use. In this case, voltage storage. Second, I specify the path inside the container to mount my volume to. In this case, slash data. So now I ran my container. The app didn't find a file. So it created a new one and populated it with data. But this time, this data is persisted outside of the container into the voltage storage volume. Let's exit the container. What happens if I run a new container, but I attach the same volume to it? This time the app should find that data.txt already exists. Let's see. Bingo! File already exists and my app just printed the contents. And no matter how many times I run the container, as long as I'm mounting my volume at slash data, the app will always find the data that was written by my first container and just print it. So now my data will survive container reboots. Not bad. Another cool thing you can do is to share a volume amongst multiple running containers. Let's try that. So now I'm running 4 different containers simultaneously. They all share the same volume. The first container I ran created the data.txt because it didn't already exist. All other containers simply detected the existing file and printed its contents. This is because they're all sharing the same underlying data. Nice. Docker also allows you to perform operations on volumes. Inspect is very useful here. You can get some valuable metadata. And if you no longer need a particular volume, you can just remove it. Be very careful because removal means this volume and all data inside it is destroyed and cannot be recovered. But one interesting thing that I want to show you is there. Docker won't allow you to delete a volume that's still in use. In this case, my container running in the left terminal is using voltage storage, so I can't delete it. There are plenty of safeguards around Docker volumes, which is yet another advantage. How cool is that? Docker gives you a dead simple interface to persist data outside your containers. Of course, what I showed you was very basic usage. You can do a lot more magic with the storage mechanism. Another big advantage of volumes is that you can extend their capability. By default, a Docker volume resides on the local host machine only. But Docker allows you to write plugins with which you can integrate volumes to different storage providers like AWS S3 or a network attached storage. And naturally, the community has created a lot of plugins for you to store your data at a lot of different places. I mean, you could even store your data on a blockchain. And now that you're a master of data storage in Docker, I have a challenge for you. Create a project to store your Docker containers data in AWS S3 using Docker volumes. It doesn't matter what type of application you create, what kind of data you're storing. No, I am interested in seeing how you use Docker volumes to store data on S3 that you produce on your local workstation, or maybe even a server, your choice. FYI, AWS S3 or any service from any cloud provider for that matter costs money to use. So make sure you understand what costs you will incur before you dive into this project. Share your strategy in the comments below. If you build the project, also share its link. I would love to see it. In the next lesson, I will teach you networking in Docker. Keep leveling up your DevOps skills with me. If you're new here, subscribe to my channel now. Your support and feedback is what keeps me going on these videos. So press a like, share this video with your friends, spread the knowledge. I will see you in the next video.